Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher. Today we are going to discuss another chapter, structure of atom. Before starting the structure of atom, let us have a quick recap of yesterday's class. In the yesterday's class we have discussed about the mole concept. So that is going to help us in learning the next chapter also. That's why I am taking the recap. In the recap we are going to have some question based on this mole concept. Yes, so first of all I'll write down the topic for discussion. Okay, so we are going to have a quick recap. In the recap we are going to see some question based on the mole concept. Yes, so calculate the mass of the following. Calculate the mass of 0.5 mole of N2 gas. 0.5 mole of N2 gas. Okay, this is the first question. Let us see how to solve it. Solution. So as we know, according to the mole concept, we know that 1 mole of any substance is equal to Avogadro's number. It is equal to its molecular weight or molecular mass, right? Yes, as we know, 1 mole of a molecule, 1 mole of a molecule is equal to its molecular weight, right? Is equal to its molecular mass, right? Molecular mass of N2. Okay, yes, as molecular mass of N2 1 nitrogen atomic weight is equal to 14. So it is 2 into 14, that is equal to 28 gram. Okay, therefore I can write down, therefore 1 mole of molecule, 1 mole of N2 gas molecule is equal to 28 gram. 1 mole of N2 gas molecule is equal to 28 gram. Therefore 0.5 mole, that is half mole N2 gas will be equal to half of 28. 0.5 divided by 2, that is equal to 14 gram. 0.5, that is half mole. Okay, this is one way to solve this question. There is another way to solve this question also. Do you remember we have seen the formula for number of moles? As we know, number of moles, which is denoted by symbol small n, is equal to the molar mass or molecular mass divided just a minute, given weight divided by molecular weight. Okay, given weight, this formula we have discussed already, divided by molecular weight. Okay, the same thing I can modify. Okay, given weight is GW, molecular weight is MW. Okay, same thing I can modify. Here molecular weight we know, number moles know, given weight we want to find out. Therefore given weight will be equal to what? Number of moles multiplied by molecular weight, right? Number of moles is equal to 0.5. 0.5 multiplied by molecular weight 28. 0.5 is nothing but 1 by 2 multiplied by 28, that is equal to 14 gram, right? So this is how we can solve this question, by these two ways. Okay, take a screenshot of this page. One more question we will discuss. Calculate the mass of 0.5 mole of nitrogen atom. Okay, previously it was N2 molecule, now it is N2 nitrogen atoms. Okay, yes, now let us see how to solve it. Yes, similarly here also, as we know, 1 mole of any atom is equal to its atomic weight, right? 1 mole of any atom is equal to atomic weight. Therefore 1 mole of nitrogen atom is equal to its atomic weight of nitrogen is 14 gram, right? Therefore 0.5 mole of 0.5 mole of nitrogen atom means 14 divided by 2, that is equal to 7 gram. Okay, so 7 gram is the answer. There is another way to solve this question. Okay, as we know, the number of moles of an atom is equal to given weight divided by atomic weight. Okay, here we know number of moles, we know atomic weight, and we can find out the given weight, right? Okay, therefore given weight will be equal to number of moles multiplied by atomic weight. Okay, number of moles is 0.5 multiplied by 14. 0.5 is nothing but 1 by 2 into 14, that is equal to 7 gram. Okay, so this question also we can solve by using the two weights. Okay, here we are talking about the atomic weight, atoms weight, and the previous question we were talking about the molecular weight. Okay, take a screenshot of this page also. Okay, yes, now after this we are going to discuss about the next topic, and that is nothing but the structure of atom. Okay, now structure of atom, so many scientists have contributed to it. So many scientists have discovered first of all the subatomic particles, and so many of them have discovered about the properties of this particle. Then so many of them have discovered about how these are assembled to each other to get the final atom, right? I'm today going to explain, going to start the first, or what you can say, this is not a first. Before this model so many other models are there. Like, first of all, let me just write down some prominent scientists in this field, and then we will discuss about the one model of atom. So first one is the J.J. Thomson, who discovered the electrons, cathode rays. Then next is the Ernest Rutherford, who has given his Rutherford atomic model, or Rutherford model of atom. Then after that it is James Chadwick, who has invented the neutrons. Okay, then after these models, the another name I'll write down is the Neil Bohr. Okay, Neil Bohr. Okay, Neil Bohr is the scientist who has given the Bohr's atomic model, which is the most, what you can say, correct, without least anomalies in it. So we are going to discuss today the Bohr's atomic model. Bohr's atomic model. So let me just explain this model to you. See, this model of atom it tells us that for every atom is a spherical entity. Atom is a three-dimensional spherical entity, 3D, three-dimensional spherical entity. That is, I cannot draw the structure of atom on a 2D paper, on a 2D board. This, what I have drawn here, this is a circle but not the sphere. Sphere, just like the football, right, that I cannot draw on this 2D paper, right? Atom is a three-dimensional 3D entity. It is spherical in shape. Okay, yes. Now every atom has two parts. Okay, first part is called as the nucleus of an atom, another part is called as the shells of an atom. Okay, yes. So what is the nucleus? Nucleus is the centrally located part, centrally situated, and shells are surrounding the nucleus, okay, yes. Now this nucleus is situated at the center, and it has subatomic particles called as protons and neutrons. So this is the nucleus of an atom. Okay, yes. So what does this nucleus have? Nucleus contains two subatomic particles, okay, that is protons, okay, which are positively charged, and neutrons, which do not have any charge, they are neutral. Neutrons, they are electrically neutral, they do not have any charge on them, right? Okay, so these are present inside. Now surrounding to this protons and neutrons, that is nucleus, the electrons are revolving. Okay, electrons are revolving. I hope you understand the meaning of revolving. Revolving in circular motion, like this. Okay, so this is called as revolving in a circular motion around that sphere. Okay, just like the earth is revolving around the sun, the moon is revolving around the earth, right? So this is called as revolving. Okay, so here, as this is a two-dimensional image, I am not able to show the sphere, but I will show the circle. Okay, so this is the first circle. Okay, the circle is nothing but the shell in which the electrons are revolving. Second one, third one, and fourth one. For the sake of understanding and to avoid the crowding on the board, I am drawing only 4. But it's not like there are always 4 circles, there are always 4 shells. there are different number of shells, more or less number of shells also, right? I am drawing 4 only to avoid the crowding here, just to avoid the crowding. Okay, okay, yes. So these are the circles surrounding to the nucleus. Okay, these circles surrounding to the nucleus, Neil Bohr has given a name to them. He has called them as shells. Okay, he has called them as shells, or one more word he has used, they are also called as orbits. So what are shells or orbits? Shells or orbits are the circle or circular paths in which the electrons are revolving surrounding to the nucleus of an atom, right? Okay, now scientist Neil Bohr has given the symbols to these shells or symbols to these orbits, like 0, 1, just like some of them give numbers, some of them give some letters, some of them give Roman number. Just like Neil Bohr has given the symbols starting from K, L, M and N. Okay, he has given the symbol K, L, M and N, K, L, M, N, O, P and so on. As here, to avoid the crowding and as there is a less space available, I am drawing only up to N. I am repeatedly telling you that does not mean only up to N the shells are present. There are more shells also, L, M, N, O, P, Q, R, so on, right? Yes. Now again he has just like the symbols, he has also given numbers to them, which is called as shell number, which is denoted by the symbol small n, right? So shell numbers are nothing but the numbers 1, 2, 3, 4 and so on. So this is the shell number 1. K shell is the shell number 1, L shell is 2, M shell is 3, N shell is shell number 4, right? So 1, 2, 3, 4, 5, 6 and so on. These are the shell numbers, right? Okay, now can you see guys, every shell is having a different size. This one is the smallest, this one is the biggest in this one is the moderate, this one is the moderate. So every shell has a different size. As the size of shell is different, obviously number of electrons that can stay in it also will be different. Just like I'll give a simple analogy, house. If it is a bigger house, more number of people can stay there. If it is a smaller house, lesser number of people can stay there, right? So that depends on the size simply, right? Okay, so Neil Bohr has given one formula to exactly tell how many people, that is electron, can stay in the particular shell, right? How many people, that is the electrons can stay in that particular shell, right? And that is nothing but the formula I will write down. He has given one formula, the maximum number of electrons calculated by the formula 2n square, where n is equal to the shell number. N is nothing but the shell number. Okay, so this formula we can use to find out the maximum number of electron, maximum. Okay, yes. So 2n square for this will be equal to 2 into 1 square. 1 square is equal to 1, therefore 2. How many electrons can stay in K shell? Maximum up to 2. 1 also, there can be only one electron also, but what is its maximum capacity? 2 electrons. Similarly, we can find it for others also. 2n square for L shell is 2 into 2 square. 2 square is 4. 4 into 2 is 8. So in L shell, maximum up to 8 electrons can stay. The next is M shell, for which n is equal to 3. So 2 into 3 square is equal to 18. So in M shell, maximum up to 18 electron can stay at a time. The next is 2n square, n is equal to 4 for nth shell. So it is equal to 4 square, that is 4 square is nothing but 16 into 2, 32. So in n shell, maximum up to 32 electrons can share. If it is O, fifth shell, then 2n square will be equal to 2 into 5 square, that will be 50 and so on, right? So this is how we can find out the 2n square, which is nothing but the maximum number of electrons that can be present in that shell by the formula 2n square, when n is the shell number, right? 2, 8, 18, 32 for K, L, M and N shell. Okay, do you understand this formula first of all? How to find out maximum number of electrons? Okay, take a screenshot of this page first of all, and then we'll see the next concept. This is the Bohr's atomic model. Okay, I'll just write down the symbols of the shells. This is K shell, this is L, this is M and this is N. He has given the numbers also. K shell is the shell number 1, L is the shell number 2, M is the shell number 3, N is the shell number 4, right? Okay, now next concept we are going to discuss. Now these shells or orbits, if we consider these shells or orbits as the home, right? If we consider these shells or orbits as the home, like K is one type of home, L is one type of home, M is another, N is another. So if I consider these as the one type of home, so according to their sizes, we will have different sizes of the home here, right? Okay, so that part I am going to tell you now, right? So Neil Bohr has further given one more thing, that is these shells or orbits. He has further classified into subshells. Okay, the shells or orbit he has further classified into subshells. Depending upon the size of the shell, the specific number of subshells will be present in any atom, right? Okay, so first of all, let us see what type of subshells can be present in K, L, M and N shell. Okay, so as I have told you, it depends on the size of the shell, right? K shell is the smallest one, right? As you can see, the red circle is the smallest one. K shell is the smallest one, so there will be very or smallest number of numbers available. So this K shell is just like, I don't know how many of you have stayed in the hostel, but when we stay in the hostel, at that time only one room is allotted to us, right? Okay, one room for one student. That one room is nothing but our house when we are staying in the hostel, right? So that does not have kitchen separately, bedroom separately, living room separately, right? Everything is just a single room. Okay, so K shell is just like the hostel room. Okay, K shell is just like the hostel room. Okay, in hostel room, as we know, there is only one room. That one room is our one house. So how many subshells are possible for K? Just one, right? Because K shell is further not divided into subshells. Hostel room is not further divided into different rooms. So it is one subshell. Then next is the L subshell. L subshell is just like one room kitchen. Okay, L shell is just like the one room kitchen. One room kitchen means what? One living room and one kitchen. So how many total rooms are there? 2 rooms are there, right? Okay, then next is the M shell, which is little bit bigger than the previous. So it is like 1BHK. 1B stands for bedroom, H stands for hall, K stands for kitchen. So we have bedroom, hall and kitchen. That means total 3 rooms we have, right? How many rooms are available for M shell? 3 rooms are available. Rooms are nothing but subshells. Then last one is the N shell, which is just like 2 BHK. Okay, 2 BHK stands for 2 bedroom, 1 hall, 1 kitchen. So total 4 rooms are available. If it is O subshell, further it will be 3 BHK. 3 BHK means total 5 rooms. Likewise. Okay, so this is how the shells are further divided into subshells. The number of subshells are fixed, right? K shell, the smallest one, only one room. L shell, 2 rooms. M shell, 3 rooms. N shell, 4 rooms, right? Okay, now after this, these just like in house also, every room is having a different name. The kitchen, living room, bedroom, study room, etc. These are having different names, right? Similarly, subshells are also having different names. Okay, just like the rooms in a home are having different name, the rooms or the subshells in an atom are also having the names. What are the names? You have to remember just one sequence here for subshells. Okay, sequence for subshells I'll write down here. That sequence you have to write down, you have to follow. Sequence for the subshells. Okay, it is S comma P comma D comma F comma G. All of them are the small letters. Okay, yes. So when it is, you have to start with S, P, D, F and G. So only one subshell means it will be S subshell. That's it. Next is the two subshell. Two means start with S always, then P. Why S and P? Because two subshells are there. Next, three subshells are there. Always start with S, then P, then D. Okay, 3. Follow the sequence. The next is 4, then S, P, D and F. If it is further, then it will be S, P, D, F and G, right? Okay, so this is about the subshells. They have the symbols. Subshells have symbols. Okay, now every subshell, which is nothing but the room, right? Every subshell, which is nothing but the room. Okay, every room, just like in every room, a fixed number of people can stay, right? In every room, a fixed number of people can stay. That is its capacity. If I ask like 20 people to sit in the kitchen at a time, that's not possible. Kitchen is smaller as compared to the living room, right? So similarly, every subshell is there. So now I am going to show the diagram for the subshells. Okay, diagram for the subshell, which will give you the number of electrons eventually. Okay, which will give you the number of electrons. Let us start with the K shell. Okay, let us start, S subshell. Right now S subshell is, you have to draw only one square for S subshell. Always remember, in one square 2 electron can stay, 2 people can stay, one upward, another downward. So what is the capacity of the S subshell? 2. The next I will draw is for P. For P, how many boxes you are going to draw? 1, 2 and 3. So how many electrons will be there? 6 electrons, right? Like this. Now why the numbers are fixed, I am going to explain you in some another class. Then D. For D you are going to draw total 5 boxes. Okay, how many boxes you are going to draw for D? Total 5. So 5 boxes means double, that is 10 electrons, right? Because in every box 2 electron can stay, 10 electron. Then for F I will draw, okay, for F subshell, how many boxes you are going to draw? 7. You can see the number of boxes are here 1, then 3, then 5, then 7, all odd numbers, 1, 3, 5, 7, 9, so on, right? So here it will be 7, 1, 2, 3, 4, 5, 6 and 7. 7 boxes means 7 into 2, 14 electrons, right? In every box 2 electron can stay, maximum up to 2 electron can stay, so 14. Then next is G. For G, yes, what I have told you for G. Then again the next odd number, after 7 the next odd number is 9, right? So 9 boxes, 1, 2, 3, 4, 5, 6, 7, 8 and 9. 9 boxes means 9 into 2, 18 electron can be there in this G at a time. 4, 5, 6, 7, 8 and 9, right? So 18 is the number of electron, right? So just like in every room of a house, the number of people that can stay in the room at a time is fixed. Similarly, this is also fixed. Okay, now you just take a screenshot of these 3 pages first of all. These are very, very important pages. If you understand this concept of Bohr's atomic model, you will be able to understand each and every concept in the particular chapter, structure of atom. Take a screenshot fast. You will never get this kind of explanation in any book. Okay, you will get a very theoretical, very bookish kind of explanation everywhere, which is really very, very confusing. So this kind of explanation, a detailed explanation, therefore is really very important. Okay, just take a screenshot again. this kind of trick, it's really very easy to remember all the things. Okay, so that's all for today for structure of atom. Remaining concepts we are going to discuss in tomorrow's session. So I hope it is clear to you. If you have any questions, please feel free to ask me in any session. You go on noting down the questions on your notebook. You can write down in the margin, or you can just have a keep a page fixed for the doubts and questions, and keep on asking me during the classes. Okay, so before ending the class, let me just show you the DPP, daily practice problem. So this is a teacher's profile. Similar will be the students also. You have to go to resources, then to writing material, then you can click on DPP. You can see the download option over here. Write down the solutions of this DPP on your notebook. Take a photograph and upload the picture on your portal, so that teacher will be able to see, evaluate, and let you know the suggestions wherever required. Okay, so that's all for today. Thank you so much, students, for your precious time, and all the best to you.